Can you see? Okay, start my video. Okay, I'm here. Hello everyone. Can you see my presentation? Yeah.
Yes. Yeah.
You started, it'll be good.
Okay. Okay, I'll go ahead on presentation mode.
Yeah.
All right. Well,
Perfect.
okay, great. Thanks, Petra, for inviting me to give that presentation about talking about the work we've done in the framework of the Research Data Alliance on interoperability between variable naming terminologies. So for those of you who don't know me, I'm Gwen Moncoiffé from the British Oceanographic Data Center, now part of the National Oceanography Center, and I lead the NERC Vocabulary Server Management Group at BODC. So as we all know, scientific variables are often semantically complex. They can be a combination of concepts, sometimes proxy concepts themselves. They're often represented with short abbreviated labels, often insufficiently explained or described in datasets. And we often require access to free text descriptions in scientific publication and human interpretation in order to make sense of them. So in the 1990s onwards, we started developing, or the community started developing centrally managed control vocabularies to try and capture unambiguously essential information about variables, or at least obtain some degree of consistency in the naming of variables. So here I just name a few: CF standard name, BODC parameter usage vocabulary. There's also the ICIS param vocabulary, and there are many more as well. So scientific variables, we've got a large diversity of variable naming conventions, and obviously this is dependent on the adoption of specific data format standards, like for example, the climate forecast convention, or some other formats that might require specific vocabularies. But it's also dependent on the community preferences, as well as obviously individual scientist preferences as well. So obviously this pose a problem, a challenge for interoperability, and it's also more challenging in multidisciplinary science, like polar data science, of course. So, but I think in your case, it's also much more rewarding, because much more can be done if data can be exchanged across disciplines very quickly, and allowing scientists to make analysis and processing across different type of data. So in 2019, following a series of discussion with a few data managers and scientists from different communities, we decided to form a working group to look at this issue of interoperability between the terminology used to describe observable properties. And it was basically our main goal was to address the interoperability of fair data, and also enable interoperability between existing terminologies like CF standard name and BODC PUV, but also we had people in our group from the earth science domain, from the terrestrial ecology domain. So it was beyond the oceanographic and beyond the environmental domain as well. So we wanted to try and come up with a framework that would be as domain agnostic as possible. And we also wanted to promote the reuse of fair terminology. So terminologies that are themselves findable, accessible, interoperable, and reusable, to annotate research data with well-identified, unambiguous, and machine-readable vocabularies. So here, there's just a few names there of my, I was a co-chair in a group of 4 co-chairs, but we also had many other participants, including Petra, who came regularly to our session and contributed a lot to the work. So the challenge was that the lack of a common framework to enable, or to address the lack of a common framework to enable interoperability between diverse terminologies. And we also wanted to make sure that there was a necessary level of detail so that data could be seamlessly discovered and integrated as well. So quite a bit of a challenge. And we had the Research Data Alliance, I didn't say, is an organization that promotes open sharing of data and and promote the work of the formation of working group to address specific issues. But they do impose a very strict framework. So we had 18 months to actually deliver our key objective, which was to deliver an interoperability framework for variable descriptions. And we managed to do that through COVID. And we published our first, our recommendations in May last year. So this was just very briefly, I won't go into the detail of that, but just to show you that we went through quite a detailed work plan that took us through many iterations. We tried to take into account as much as what was already existing as possible. And it was quite an involved piece of work. And we surveyed many vocabularies or terminologies that were used to describe variables as well. And we went through all sorts of analysis, and this is just the end result of a very complex process that saw us do a lot of those spaghetti diagrams, where we actually try to pin down, okay, what are the common elements among all those terminology? What are the common requirements across all use cases? And we ended up with quite a simple framework, really, where we have 4 main, what is called ontological classes, which is at the top level. So there's 4 classes in that ontology or that framework, and 6 properties. But I'll go to the next diagram that is a little bit more easy to understand. So at the top level, you've got the variable. The variable is a complex concept that is composed of at least only one property. So only one measured property should be associated with that variable. And it is also associated with entities, but the relationship that variable has with entities will depend on what is that entity with regards to that variable. It's a bit circular, but so basically an entity can be either have the role of object of interest, it can be a matrix, it can be a context object, and you have, at the minimum, a variable is made of a property and it is made of an object of interest. So imagine temperature of the water. The water would be the object of interest, the temperature would be the property, or concentration of nitrate. Concentration is a property, nitrate is the object of interest. The variable may also have some constraints, which enables us a certain flexibility. For those of you who are familiar with CF standard names, for example, you will be well aware that a variable is rarely just an object of a property and an object of interest, but it also has some constraint with regards to the way the measurement might have been derived. So this is to give us some flexibility. So really, the IADOPT ontology, and it's about the decomposition of a complex concept, which is what is being measured, into atomic elements that enable us to more easily describe it consistently, but also enable better aggregation, maybe, as well as interoperability between different terminologies. So this is just an example of a decomposition. Imagine you've got a data set with mean concentration of nitrate in precipitation water, and then here in that case, it is at a specific site. It also specifies a unit, and it also specifies sampling. So really, this is just to highlight that we are only focusing on the variable aspect of that. So we are not interested in the feature, which is the MRC cost. We are not interested in addressing the procedure, the process, or the methodology. We only wanted to focus on the observable property. And in order to create terms that could be then reused and put into the context of more complex data schema that would have means to deal with methodology and feature and units. All this is all very important, but we didn't want to step into that. We wanted to purely focus on the observable property. So this is just an example of an alignment that we did very early on. So I must say this presentation is based on a patchwork from multiple presentations I've done in the past. So and colleagues of mine have done in the past. So it is it's work in progress. So some of those are no longer valid, but it's just to show you the kind of approach that we've taken. So on the left there of the slide, you've got two terms, one from P07, which is a climate and forecast standard names in the NERC vocab server. And you've got the P01, which is the BODC parameter usage vocabulary in the NERC vocab server as well. So those are really complex concepts that are represented by a unique URI with a code there on the right hand side of that left panel. So the idea is, for a long time we've wanted to align CF standard names and BODC parameters usage vocabulary, but with both vocabularies being very detailed and very very narrow, very detailed, it is very difficult to actually align those two vocabularies, almost impossible. And it would be very cumbersome as well to actually maintain all those mappings. So really the use of the IDOPT framework for aligning those two complex